So today I'm going to talk about how to enhance AMP with PWA. We already seen like a great talk from Sanj about AMPs, and I want to just try to go to disrupt what it says, and I want to try to sneak in JavaScript on in AMP. Closer, you see the first one. Right. I'm Mattia, as I said. I'm working at DAZN. If anyone doesn't know what DAZN is,
How do you pronounce it?
no one knows. DAZN is like on my interview, I spend most of the time try to know how to pronounce it. I still don't know, but I guess it's DAZN.
What does it stand for? DAZN?
I don't know actually. I don't think there's like acronym, but yeah. But what we're doing, that's why I know, is like Netflix, instead of being for TV and movies, is for sports. You won't see it soon because like rights for sports in UK is too expensive, but we exist in different countries. Right, so that's the agenda of today. I'm gonna have like a brief introduction when I'm trying to convince you to use these technologies. I'm trying to scare you mostly. And then I'm gonna start talking about AMP, like a brief introduction, because we have already an amazing talk about it, PWA, and how to merge them together. So this won't be new for you because like Sanj already mentioned, but 53% of the user leave the website after 3 seconds. So if the app doesn't load in 3 seconds, they leave. And sadly, 75% of the mobile website, it takes more than 10 seconds to load. And this one is just like another info. It's like the website, mobile website that loads in less than 5 seconds gets twice the revenue for the slower website. So the question is why they are so slow. There are many reasons. One of the main reasons is like the size of the website, because like since when we had iPhone 2, iPhone 3, we increased a lot the speed, the performance of devices. We had a faster connection, but on the same time, we increased a lot the size of our website because we increased complexity, library, framework, and so that's just an example. This one is just like an average data. There are more than 800 kilobytes just for loads ads, more than 1.5 megabytes for content. In general, it's like more than 2.5 megabytes weight as an average for mobile web page. You said 15 seconds, I found 13, but that's slow, all of them. And as an average, we are making about 200 server requests every time that we load the app, and where half of them is like related. So the question is, how can we fix this? We can use AMP, and where the AMP shines to me is like restricting our development, because like we can achieve whatever AMP is giving to us. We don't need AMP for that. But AMP is just like constraining us to follow best practice. And the way how it does is like, it's banning JavaScript, so it's gonna get rid of JavaScript. The only one who allows is its own JavaScript, so the library of AMP. And then it's gonna use like custom component, it's like abstraction of the normal HTML tag. And those ones, it just like allows you to restrict and to expand the HTML tags. And you also have like a reduced size for CSS, so just inline CSS, and it's to be up to 50 kilobytes weight. So really brief introduction, reintroduction, because we've seen already this. But the main components are AMP HTML. This one is like the basic declaration of the HTML. So you do have, I told you, I'm just like bouncing my voice. You do have like HTML, and then you do have like a link. I'm just going through the most important one. In the link, you do have like a refer or the normal version if AMP is not supported. And then you do have like a viewport where you can decide the width, length. I didn't type the whole thing. But that one is used by AMP to speed up the render of the page. And you also have the only script that you're allowed to have. That's the AMP project library. So then we got the AMP.js. AMP.js, as I told you, is like a library that restricts us when we're developing an application. And it tries to force us to use the best practice. Then it's going to manage the external resources, because what it does, it loads asynchronously every resources that we need in our app. so it doesn't create the bottleneck of like different resources. Then restricts the tags you can use, as we've seen earlier, and calculate that one is a way to speed up the process, calculate the page size, and when it does, converts the AMP HTML that we are strict to use to a normal HTML. Last but not least is the AMP cache. The AMP cache is like, to me, is the real player in this AMP technology. What it does is like resizing and match the viewport. So if you do have like a smaller device resolution, it gives you like a lighter version of the same image. Then has inline CSS, magnification CSS, and does a pre-render of the page before loading in the background, before loading in your app. So the benefits are more than one. The most important one is that we're going to have like a fast loading time and a fast interaction. So as you can imagine, a lighter website, it loads like faster, and the interaction itself is going to be faster itself. We're going to have like a pre-rendered page, and then we're going to have like a enhanced SEO. How do you pronounce it? SEO, yeah, thank you. Just because it's powered by Google, give us like this present to have like this like feature. And then, as has been mentioned already, Google will show your version in the top stories on the Google search. These are like just like a few stories, few examples of like company that successfully implement AMP. I guess Compare the Market is another one, and they achieved like a lot more using this technology. But there are one issue to me. We won't have like a richer user experience, because as we've seen earlier, we do have like a lots of restriction. So we're gonna gain a lot of speed, but we won't have like a rich user experience. And the reason why we won't have it is like because we can't use JavaScript. The images are lazy loaded, and what I mean is like it's gonna load just the page that inside the viewport, wherever like outside the viewport won't be loaded. There are some tricks, but mainly this. You cannot track the activity of the user. You won't have push notification, offline support, and this one is why they say that Google AMP is evil, because like the pre-render with other like feature will be given to you only if you host your AMP application on the Google CDN. If you won't use a Google CDN, this tool won't be given to you. Of course, you can use a different CDN, but if you want to have a pre-render, you have to use the Google one. So on the other hand, we got progressive web app. Okay, so PWA. PWA are progressive. That means you can run in every browser. Are responsive because you can use in every devices. They feel like an app, a native app. That's why you can install them, and you can use like in offline, so you don't need to have like an internet connection. So in this graph, I'm gonna just like show you where AMP wants to stay, because like we do have, using mobile web application, we do have like a reachability, because we can serve the app to any, let's say any kind of devices, but we lose capability. Instead, if using native apps, we're gonna have a lots of capabilities, but we won't have like the same reachability of the mobile web. So PWA wants to stay in the middle of them, wants to get both benefit and try to give you like the native app capability with like an amazing reachability. It's really complex words to say together, reachability and capability. Right, so which are the main requirements? PWA uses HTML5, but the key point are the service workers and the web app manifest. So the service workers is just like a client-side proxy that sits between the application and whatever API, whatever backend you're calling it. So in this case, as you can see, the service workers loads and caches all the resources that your app would need. So as soon as the app try to get any data, the service worker intercepted and decided to get from the cache if it exists, or calls outside if it doesn't exist. The web app manifest instead is just like a JSON file that describe your app. So mainly you do have like a name, the icon you want to display, and that one is used to have, that one allows you to install the app in your mobile phone. Of course, once you got the manifest declare, you need to import in your HTML, as you've seen there, just a link, nothing fancy. But even PWA has like an issue, because like it's amazing, it's really fast, performant, but it shines only on the second load. So the first time you're loading it, it won't give you the benefit that you're using PWA for. So the question is, how can we try to fix this problem and the AMP problem, merging them together? Because as we've seen earlier, AMP allows us to have like an instant loading, but doesn't give us a rich user experience. So taking them both together, we can try merge them and having both benefit from AMP and from PWA. There are many ways to merge them together. There are mainly 3 patterns. The first one is like AMP as PWA. What I mean saying AMP as a PWA is like we're still using AMP, so the AMP technology, the AMP libraries, but we're going to inject in AMP the PWA boost, let's say, because as we've seen, PWA give us the offline and user experience. So in this case, what we can do, we can take advantage of the AMP install service worker. That is the component that's been already mentioned. So of course you need to inject it. And again, the script is just AMP project, nothing different because it won't be allowed. But at the same time, AMP itself gives us the possibility to install the service worker. So as soon as we install, just using that component, we can take advantage of the offline access. And this one is just a snippet for how it works. So when the app tries to fetch any data, it opens like a cache, and then with a cache open, it just performs as an initial like step, like a match. So in the first return, I don't know why I had so many colors. Sorry for that. That wasn't me. So the cache itself, it tries to match it. So wherever you're asking to retrieve, it checks if exists. It's the same behavior that the PWA does. And if exists, gives you back. Otherwise, it's gonna call the network. And when the network comes back, it's gonna, of course, give back to the AMP application, but it's gonna save in your cache. So next time you're gonna call it, it's gonna be ready to go. And second, we're gonna have custom.js, because as we've seen earlier, AMP doesn't allow us to have JavaScript. But combining them together, we can trick them. So the way it works is like, just a step back. Earlier I mentioned the AMP cache. The AMP cache is the one who served the data to the application, but at the same time performs a validation. So what it does, it runs through the application, it checks if you like in line with what is required by the AMP. And if you see the green icon that San showed us earlier, you're good to go. So in that case, if we would have had the script inside the HTML, that won't be validated. So the AMP cache won't allow us to have it. So in that case, we can have like the simple AMP application, like as is being required. But as soon as it comes back in our application, so in the cache in our app, we can change the body and we can use the script that is used to power a richer user experience. So the benefit of this is like having, with this pattern, AMP as PWA, allow us to have like offline access and custom.js. The second pattern to use them together is AMP to PWA. So in this case, we're going to keep those applications separate between them. So we won't inject any power of the PWA in AMP. We're going to keep them separate. But we're going to use AMP as a bootstrap. So as you can see here, AMP is going to be the first app that is going to be loaded and seen by the user. So we're going to have like an instant load for the user experience. But at the same time, while the user is like start interacting with the app, behind the scene, the AMP is going to install the service workers. So as soon as you install the service worker and all of the resources needed by PWA would allow the user to be redirected to the AMP application, sorry, to the PWA application. So it's like a trick. You start with a fast, let's say, less fancy application, but behind the scene, you're gonna get ready for whatever is like the more performant application. So as soon as the user interacts with that one, it's gonna leave, let's say, the AMP application, is gonna move to the PWA application. So you will see benefit of both worlds, instant load and like a richer user experience as soon as the users start interacting. And the way how it does is like, first of all, install the service worker. This one is the one we've seen earlier, so it's still using the same approach. Second is gonna cache the resources. These resources are the PWA required resources. And as you can see, as soon as it starts installing the app, and when install in the cache, you see cache add all, and then you can specify every kind of file that you need to boot and to speed your PWA application. So you can have like CSS, JavaScript, whatever you wanted. So doing this, as soon as the user interacts with any of the AMP application, he won't see the AMP anymore, but it will be redirected to the PWA. So we're gonna have, this one is my favorite approach because you will have like advantage of both worlds. So you're gonna have instant load and like a richer experience just next. But the question is, what happens if the browser doesn't support the service worker? And we do have like a solution for that. Because as you can see, this is the same component that we've seen earlier, but there are two more like key. And one is like URL match and shell URL. What those are doing it is like they're gonna check if the application has the service worker installed and so all the resources. If they are not, so we'll understand that won't be supported. So what it does, it just redirect to the PWA application outside this environment. This one is the last pattern and is AMP in PWA. This one is the opposite of the first one that we've seen it. So instead of like having an AMP application and injecting the PWA power, this one is the opposite way around. So we do have like a PWA application and we're going to inject the AMP power. Seems fancy. So what it does is like this one, as you can see, the PWA is made by mainly application shell and the content. The application shell is the one who has been like cached and loaded in your application. But on the other hand, the content is going to change by the user interaction. So you will be required to fetch data every time the user changes the content. So what it does, this kind of approach, PWA hijacks the navigation clicks. This one is something that it does by out of the box. Then the XHR fetches the requested from AMP page, puts the content in the shadow root, and then attaches wherever we paste in the shadow root in the HTML, so in the DOM of the application. This one is like, I'm trying to simplify the process. So imagine that instead of having AMP down, we would have, usually it's like a backend there. So the progressive web app, every time that the user interacts and changes the content, is going to fetch the data to the backend. And usually we're going to use like JSON or JSON like call. But in that case, instead of like calling the backend straight, what it's going to do is going to use the AMP pages to retrieve from the backend the AMP validated and so light version of the content, and it's going to paste in. Right. Let's go back to this picture. So imagine this one. The content itself could be like a normal content. So we're going to have like call the backend, retrieve the data, JSON data, and we're going to render inside the page. But this kind of behave could take longer because, like, let's say we won't follow the best practice. So this approach allows us to use within the content that we are pulling it, the AMP page document because they are lighter, as we've seen earlier, validated, and so faster to render in the DOM. How it does is like, again, it uses an AMP project to get the shadow root, and then it gets the data from using XHR because fetch is not supported. And then as soon as it gets the data from the AMP, it's gonna create like a container in the HTML. This one is, let's say, the URL where the AMP pages are hosted. And then it's gonna, through the AMP untouched shadow doc, is gonna paste in the new content that we got it. So the benefit of this is like it's always fast. So we start fast and we stay fast. We got like a great distribution built in. We got like a progressively enhanced, and we got one backend to rule them all. It's like, as I said earlier, we got just one data source, and then we're gonna have less complexity. These are a couple of links. There's like the documentation of both technologies. There are lots of information there, and thank you.